All right, so this is section 1-3, number 20. So we have to justify each step along the way, right? That's what we're doing. So we look at the first step and ask ourselves, how did we get from what we began to what we see in the top right? And then every step down, we think the same thing. So the first question is the following. How do I get from what I have over here, this entire part over here, to over here? What's happening here? What's occurring? Mara?
Distribution.
Yeah, you're taking this 4 that's out here, and you're distributing it to the x and the 1, which gives you this line right here. So the first answer is going to be distributive property. Then I ask myself the next question, which is kind of similar, right? How do I get from this line right here down to this line right here? What property tells me that when I multiply by 1, it's the exact same answer as what I had? Think about the word. It's the exact same answer.
Identity.
Good. Identity. And that's the identity of multiplication, right? So we should put that, because identity of addition is adding 0, right? So identity of multiplication is multiplying by 1. Now, I'm at this part right here, and I suddenly realize, you know what? I have it in this order, but I'd rather switch the order. I want to flip-flop the order. When I switch the order of something, Isabella, what does that tell me I'm using?
Wait, I think it's associative.
The other one? The associative is the next line where you change the parentheses locations. That's how you associate.
Okay.
But when I just switch the order, remember what I said? You go back and forth from school. It's called your what every morning? Your morning commutative. Very good. Because you're switching the order. Think about going back and forth to school, going in one direction and then going in the other. That's what I'm seeing here as switching the order of these two parts. And that's of addition, right? Not multiplication. I'm switching the order of the addition operation that's going on. So I really should specify, by the way, when I'm doing this. So on a test, I was very lenient, you saw in your quizzes, right? I was being pretty nice. But you should specify like identity multiplication, commutative of addition. Because they're very different things if they're not of one or the other. Then, Isabella, we can see that we go from this line here to this line where the grouping suddenly changes. That's where we have associative. And then last but not least, if I go from one line and I simplify it, what was the actual name for this that we should use? You don't just write simplification. There's an actual term for it. Substitution. Okay. Any questions on that? Sometimes the memorization of names can be difficult, especially if you didn't see this in your middle school courses. Some algebra courses are really dropping this in middle school, which is unfortunate because you're going to see so much of this in your advanced geometry, and then if you get to like calculus with proofs, you're going to see this all the time where you have to give validation for whatever step. These are simple, right? So it's not really needed in this sense, but when you get to actual proofs where you're doing geometrical proofs, you really do need to have some rationale behind what you're stating. So the rationale is on the right in red, okay? Notice you all come from different middle schools. That's why it's sometimes at the beginning of the year there's a bit of a learning curve. I know some of you are no problem with this topic, I've noticed, even on the quiz. And others really are struggling because you probably haven't seen it yet. So just, kind of get yourself acclimated. If you haven't done this ever and it's new, that's okay. It's totally all right. It's just something you have to work a little bit harder on. There's going to be stuff that you learn later that you're like, I already know this, and others don't know that part, right? Because you're all coming from different locations, different math teachers, and different schools. But this is something that is important, especially carrying on in your math curriculum, not just in this course. Questions at all? All right, other problem set questions. Julia, go ahead.
1-1, number 40.
In section 1-1, we're looking at number 40, which means it's probably one of the challenging ones, right? At the end, if it's number 40. So let's take a look. Okay. Oh, it's one of those, huh? So you just want to practice one of these again? All right. So it says the following. A is the point -5, and B is the point, or coordinate 1. I should say coordinate, really. I'm on a number line, right? I'm on a number line here. And number 40 says Find the coordinate for each point described. Each point that is half as far from A as it is from B. Half as far from A. Who thinks they're like a pro at this by now? Anyone really confident in this topic yet? Or close to confident in this topic? You want to give me a starting point, what I should do? You can use your notes from your problem set if you want, what you wrote, but give me a starting point at least.
Draw a number line.
I agree. It's nice to visualize, right? Okay. And it says again, half as far from A as it is from B.
So first I count up the points in between.
Which is what?
6.
Good.
And then I say, well, if it's half as far from B, it means it's 1/3 of the way there.
Okay, so probably like in this location somewhere, right? Again, this is A, and this is B.
So then I would probably test -3 to see if it works.
And -3 would work, actually, in this case. But that would only give me one of the answers, right? That would only give me one of the answers.
I know the other one is closer to A than it is to B.
So it's on...
That side. So I keep whichever in between my double. And
Okay. So she's doing this, and this is okay if you do it this way. What Regina is doing is she's visualizing what's happening instead of using a natural algebraic approach. So she's saying, I see this as 6, and if it's half as far from A than it is from B, it's kind of like splitting it into 3 segments. Think about it as 2, 2, and 2, which makes this distance right here 2, makes this distance right here 4. So that works right off the back end.
But I did the other test and I got points taken off.
But you didn't get the right answers on the quiz, don't forget. Come see me, I'll go over it for you. We'll look at it together. So here we have 4 units, here we have 2 units. So this is half as far as this. On the other side, what she's picking up on is the fact that if this is already 6 units, if you just move another 6 units to the left, which would be 6 behind -5 would put you at -11. This is another 6 units here. It means it would be 6 units away from A and 12 units away from B. So the other answer of -11 would work there. Now, again, that works. If you can see this by inspection and you give some sort of reasoning and not just an answer, by all means. But you got to give some sort of thought process. Like anytime on my test, unless if it's multiple choice, you get the answer right, no work is necessary whatsoever. And I'll go with the format today. It's going to be multiple choice in the beginning. You're going to have some short answer stuff and then stuff where there's longer answer problems. This will definitely be longer answer. So if you're going to take this approach, I need some logic, some reasoning, some explanation. Like what I'm doing even here is at least something. 2 and 4, I can see that's 6. This 6 and 6 is a total of 12. It's 6 away from A, it's 12 away from B, that's half as far. But some sort of reasoning behind it. If you're not going to do this by inspection, by just looking at it, then you should start to think about what's happening here. So I look and say to myself, well, if it's half as far from A as it is from B, it means it's closer to A. If it's right here, this is the point we're looking for. And I want to know this distance here is half of this distance over here. Again, this distance here is half of this distance over here. How do I represent this distance in variables? How do I represent this distance I'm pointing to right now in variables? Yeah.
X minus A.
Yeah, x is the bigger number, a is the smaller number. So that's clearly x minus a. Then I want to represent the other distance here. And which is, yeah, go ahead. Good, and it's b minus x because b is the bigger thing now and x is the smaller thing in this case. And in this case, it reduces to a fraction of 1/2 because it's 1/2 as far. Had the problem stated it's 1/3 as close to A as it is to B, or 1/4, this would just change the fraction involved. A and B are known. Some of you tried to do this on the quiz without plugging in for A and B. Be careful, you need to plug in for those. So there's A, and B is what, 1? Yeah. And there's B. And now you can cross multiply and solve this. The other answer has to do with a point that's out here. That's out here. So I first need to see that this distance, again, is half of this distance right here. What is this distance between these 2 points? How would I write them down? Isabella, how would I write these down, you think, if I know that I'm looking for this gap right here? A minus x, I agree. So what do you recognize, Isabella? How is that different from the previous one?
A is the bigger number.
Yeah, so you just switch those two, right? And in the second case with the denominator, if I'm looking here at this like giant gap here, b is still the bigger number, x is still the smaller number out of those two, so b minus x doesn't actually change at all. This is still b minus x, and now again it's equal to 1/2. And then I go about my solution by again plugging in for x, for a and for b. A is -5, b is 1, and that equals 1/2. So these are my two equations that I'm going to solve by cross multiplication. Okay? This is one of the times that you'll see cross multiplying is useful. It's not always very useful. Some people just overuse it actually. But at this point you would multiply, distribute the 2 to both, distribute the 1 to both of those. Same thing here. Double negative makes the positive. Julia.
I know I probably get credit off for this, but on the homework, I got the same answers for the fractions. I got x minus a over x minus b, and then x minus a over b minus x, but I still ended up getting the same answer.
Okay, let me explain why. I can show you why. It's not a coincidence. So check out what Julia's saying. This is actually really important. So she had this part right. So she wrote that one down correctly. But she mixed these up in both cases, it seems, right? That's what you did, literally? So, by switching the order of a subtraction, in essence, you're multiplying by -1. But if you multiply the top and bottom by -1, does it matter in math? That's how you get a common denominator, right? By multiplying the top and bottom by the same thing. So Julia, if you switch these two and switch these, in essence, there's no effect on the problem. You'll get the correct answer.
But I also switched the first one. The first one I had x minus a over x minus b, but I still got the same answer.
You had x minus a over x minus b.
Yeah.
And for that one, you told me you got, what'd you get as an answer?
-11.
No, so that answer was -3. Did you get -11 twice?
And then the bottom one, the other fraction, I had x minus a over b minus x, and I got -3.
Okay, it's not that. So you want to switch one of them, not both.
Yeah, for both of the problems.
Well, then you're just switching up your two answers. But you should, the correct way to do it is the bigger minus the smaller. You really switch everything then. So you ended up getting the answer for one where you should have gotten the other, and the answer for the other where you should have gotten one. If you switch both the top and bottom, though, like I was saying, then that has no effect, and you would get the same answer. But you switch this, and you switch this, which means you probably got opposite answers for both. It works because of the fact that there's two answers here, okay? But just try to write it the right way, you know? Trying to think of anything else for this. So again, please take the algebraic approach when you can. I really would recommend throughout the course that you take algebraic approaches. That includes word problems. Like luckily, this first test should be really easy because we haven't gotten to section 1.7 or 1.8 and even 1.9 I think partially. No, we did say 1.7. 1.8 and 1.9 have all word problems. So next chapter or next test, we're going to have a lot of word problems on the test, which you don't have to really worry about so much here. To solve word problems, I want algebraic approaches. Let x equal this. Define some variables. Use the variables to solve for. Don't just try numbers. But if you can solve this one by inspection, show your reasoning and your rationale to that inspection that you're using to come up with those answers. What do I mean by I say inspection? It's the third time I've used it today. When I say you're solving it by inspection. Inspection, yeah.
By just looking at it.
Yeah. By being able to look at it and analyze. Okay? Looking and analyzing it. Not just going through algebra for that. Others on the problem set. I saw your hand before, that's why.
Yeah,
What do you got?
it was, I think it was 1.6, yeah.
Number?
Number 20, 22, 24. They're all like the same.
Okay, let's take a look. On 1.6. Okay. 1.6, number 20. Simplify. You may wish to check your answer in a calculator. Okay. So we've got 24 minus, this is number 20. 24 minus 6t squared over 2. That one?
Yeah.
Yeah? Okay. So when I see a monomial, this was one of the things that we talked about with division, one of the rules. When there's a monomial, one term, in the denominator, you can divide it into both terms or all terms of the numerator. That's the easiest approach for this. The other thing you can do is factor stuff out of the numerator. Now, obviously, you can factor a 6 out, but 6 doesn't cancel with 2. So it might only be useful here to factor out a 2 at least to reduce it. So there are 2 ways to approach this. One approach is literally breaking it up, like I was saying, like this. Not even factoring out anything, and just reducing this to be 12 minus 3t squared. And that's fine. You don't need to factor this. Obviously, I know if 3 comes out of both and you're left with 4 minus t squared, that's fine. But there's no necessity to take out the 3. So this is a fine answer.
So that's right.
You can leave it like that, yeah. Or you can do more. Or you can do it by factoring the numerator. Take out 6 first. Leaves behind 4 minus t squared over 2, right? And then 6 over 2, what does that reduce to?
6 over 2 is right.
Yeah, 6 over 2 is just 3.
You get the same answer.
So you end up getting this, right? Which is inherently the same thing. Can you see that? Yeah, I guess you can kind of see it. Can you see this? Okay, this is the same thing. So either way is fine as an approach. Okay? Remember that when you have factors, factors can cancel. So if I look, I want to point this out actually, because this is something throughout the year that students struggle with. These are factors of each other right here. Take a look at these two. Because there's a multiplication symbol right here, these are factors. So factors can reduce. If I reduce these factors, I don't have to worry about this one here. I'm allowed to cancel these as far as possible, and 6 divided by 2 is 3. But by breaking it up into each like this, well now 24 is really factors. 24 inherently is 12 times 2, isn't it? So really, I'm just canceling the 2's like that and leaving behind a 12 down here. I'm just factoring it, really. Whether or not you're seeing it, that's actually what's actually happening there. And the same thing here. 6 is multiplying by t squared. So I could just take the 6 and the 2, those two spots right here, reduce 6 over 2 to become a 3, and the t squared gets carried down. These are just some rules of algebra and rules of simplification that you need to be somewhat familiar with. Okay? Yeah?
I was having trouble with 1, 7, like 1, 2, and 3.
Let's take a look. Guys, this is great that you're asking questions. This is how we should have reviews every time, because I want the review to be focused on what you need help on, not me just going over problems for no reason. You know what I mean? So review days should be like this. Number 1, 2, and 3, 1, 7. Check your work when there's a single solution. Okay. So Regina, give me a little background. What's giving you trouble here? So the first one was this, for example. Right? So,
Don't know how to set it up.
okay. So when I go through a problem like this, I always ask myself the following. What is happening to X? What can I get rid of that's happening to X? So the easy way to think about it.
Yeah.
Okay. I was going to say, this is just an algebraic problem. You good on this?
Yeah.
Okay, so it wasn't 1 through 3, was it?
It's 1, 2, 3, and the historical.
Okay, the historical note. Okay. That's okay if we go over this, though. Are people okay with this? Okay. All right, yeah, I see it now. A number added to 1/7 of the number is 19. What is the number, right? That was the first part. So let's take a look at this. So a number, when I hear a number, what do I put?
X.
Any variable, right? Any variable. X is fine. A number added plus to 1/7 of that number. What does of mean in math? What does of mean? Awesome. Awesome. What do you got? Multiplication. Very good, Sebastian. Multiplication. So a number added to a 1/7 of that same number, that's how I would write that, is 19. And then it says find that number. So when I do a problem like this, I would start by multiplying by 7 right away, or adding the 1 and the 1/7 together. That's fine also, but it makes it easier. You can multiply it by 7, or you could just make this fraction 7 over 7, and then 7 over 7x plus 1 over 7x is 8 over 7x. Which way do you prefer? Do you guys like clearing out denominators, or clearing them out? So you can multiply this whole thing by 7, multiply this whole thing by 7. It makes this 7x plus x, and 7 times 19 is going to be 1, what do we got? 33. 7 times 20 is going to be 140, so I'm guessing 133 because I'm missing one of those 7s, right? See how I do that math, by the way? Let me show you that one real quick. Take a look up if you didn't get that quick. If I want to do 7 times 19 in my head, do 7 times 20 because I know that answer. And what is that really? Just 140? Because 7 times 2 is 14. But I don't have 20 sevens. How many sevens do I actually have? I have 19 sevens. So I'm missing one of the sevens. So that's how I would get 7 times 19. Okay, just to make it nice and simple for me. Mark.
What if you just multiply everything by 7?
I'll go through that in a sec. Hold on. So I got 8x now. It's going to be the same answer, but I'll go through that. 8x equals 133, and then divide both sides by 8. And divide both sides by 8. What do you get? Because this is not going to be an even answer or not an even integer. What do you end up getting for this? 16 and 5 eighths. Is that correct? Right? So 0.625. 16.625. So if you don't want to multiply by 7, instead, you would need a common fraction to be adding. So I'll show the alternate approach over here. So I would start like this. I would write this as 7/7 x plus 1/7 x equals 19. Why am I allowed to write 7/7? What's 7/7 really? It's just 1. So I can do that by changing it. This becomes 8/7 x equals 19. Because 7/7 and 1/7 is 8/7. Improper fractions are okay. They are completely okay. They are allowed. You can leave things with improper fractions. Stop, the whole 3rd grade thing where you learn. It's a good skill to convert between improper and mixed numbers. You should know how to do it. But for some reason, when you're really young, you're taught you can never leave anything as an improper fraction. That's absolutely incorrect. You're going to see it more and more in math, and you're going to leave it as an improper fraction and not a mixed number, actually. Okay, so it's okay to have improper fractions along the way. Now, this one we can get rid of. How do I get rid of a fraction that's multiplying? Multiply by its what? Reciprocal. So just multiply both sides by 7/8. And we'll get the exact same answer. Okay, 7/8 of 19 will be 16 and 5/8. Yeah. Yeah. You want to do like the setup at least? How to write it out? Sure. Hey, and by the way, just the FYI, just so you're aware, the historical notes 1, 2, and 3 are kind of a lead-in to section 1.8. 1.8 is taking words and turning them into symbols, which is what we're doing in this historical note portion. So on your test tomorrow, there won't be heavy stuff on this. It won't be as heavy on taking words and turning them into equations. You'll mainly be given equations, and you have to solve them, or maybe I'll give you like that height function from class with initial velocity, that kind of stuff, and do one of those kinds of problems. Historical note number 2 says a dog chasing a rabbit, which has a head start of 150 feet, jumps 9 feet every time the rabbit jumps 7 feet. And how many jumps will the dog catch up with the rabbit? I wouldn't even go with that algebraic approach here. I would just kind of look at the problem. How many feet is the dog catching on the rabbit every jump? If the dog jumps 9 feet and the rabbit jumps 7 feet, 2 feet every jump, and he's 150 feet ahead, 75 jumps. Does that make sense what I'm saying, to do it that way? But if you wanted to mathematically set it up, it would be 150. No, it would just be 150. So this is like the head start, D, divided by the jump length for the dog minus the jump length for the rabbit. That would be the algebraic setup, which becomes 150 over 9 minus 7, which is 150 over 2, or 75 jumps later. So after 75 jumps of the dog and the rabbit chasing each other, they'll be caught up to one another.
I got the same answer, but I did 7x plus 150 equals 9x.
So what she's saying is the following. That's fine. So this is the rabbit's y-intercept, or starting point, right? The y-intercept in math is called the starting point. The rabbit starts 150 feet in front. The rabbit jumps 7 feet every jump. X is known as a jump. Let x be the number of jumps. That's our let statement, right? Let x equal the number of jumps. So the dog takes a 9-foot jump every jump, and we want to see when those two things are equal. Absolutely, that works great. Yeah, I did it with like physics distance over the two different things, but this is the exact same thing actually here. Okay? Good approach, Julia, good approach. The number 3 says, yeah, this was one of the trickier ones here. The wording for number 3 was just really, really difficult. That's why this one was tough, because of the wording. If B gives A 7 of something, dinars are just money. What is dinars, by the way? Anyone know what unit of money that is? It's not a typo. It's not supposed to be like dollars or something. Dinars are a certain type of money. I don't know which type. Anyway, so if person B, call yourself person B, gives person A 7 units of whatever money they have, then A will have 5 times as much as B. Then A will have 5 times as much as B. So if B gives A 7 of them, A will have 5 times as much. If A gives instead 5 to B, then B will have 7 times as much. How much does each have? Why am I giving 2 scenarios here? Why am I giving 2 scenarios? It's really important for this problem. Why am I giving 2 scenarios and not 1? Your summer packet, you did this a lot. You solved not just one equation. What do we call that? Do you remember? You're solving a system of equations here. 2 equations, 2 unknowns. We don't know how much money A or B have, which means we have 2 things we're solving for. So I need 2 scenarios here. So let's write it out now. So we've got, write it as, if B gives A 7 of something. So, that's how I would think of that right away, right? B minus 7. If B literally gives away 7. Then it says, then A will have 5 times as much as B. So take a look at what I'm writing. Okay, A has 5 times as much as B has. Should it be A plus 7 or just A? Let me think for a second.
I put B minus 7 is 5B plus 7.
So you did it all with one variable then, right?
Yeah, then I did it.
Well, if you did it all with one variable, you wouldn't need a second equation to solve, right? I'm trying to write it as a system. I'm trying to think if I should have a plus 7 or not on the A part. A's new value is this, right? So I do have to put a plus 7 here. Let me explain my thought process there. So let A and B be the amount they started with. Okay? Let me explain the reasoning behind this. So if A is the amount A started with, and suddenly A gains $7 from B, this is how much A currently is. A has to be 7 more than what it started with because it gains 7 from B literally giving 7 away. B started with B, but it loses 7. So this is how much B currently has. And the book says, if this happens, then person A will have 5 times as much as person B. So this is how much person A currently has, which is 5 times as much as person B currently has. That would be the first scenario. The second scenario says, and this is why we need a second scenario, if instead A gives 5 to B, so instead if A gives 5 to B, let's see how they're related now, then B will have 7 times as much as A. So that's where that becomes. So the new B, so B started with a certain amount. Once $5 or 5 dinars is given to B, this is how much they currently have. And the current value is 7 times more than the current value that A has, which is A minus the 5 it lost or gave away. So these would be your 2 equations. Seriously, for tomorrow's test, don't worry too much about this. We're going to do a lot of this with systems in the next 2 or 3 chapters. Okay, I'll tell you now, it's not going to be tomorrow's test. It's kind of a problem. But it's a good question to go through. Okay? But that would be the setup you would use to solve this. How would I solve it? I would use a system of equations. I can use elimination or substitution. Either method is fine. We haven't gone over those officially yet, so I don't assume you know them. But based on looking at your summer packets, I'm sure I know a lot of you know how to do that really well. So you're welcome to solve this and continue it. And if you struggled on the problem set on this one, don't worry too much. How many problems were on the problem set? Anyone know? Did anyone actually count them? What would you estimate? 70, 75 or so, maybe something like that? Yeah, so one problem is not the end of the world. So even if you had trouble with this one of the problems, then don't worry so much, okay? And usually I'm pretty nice. If it's out of like 75, I'll make it out of 80 and give everybody a free 5 points out of 80 or something so it rounds up and then I can do it. So I wouldn't worry about grading wise. And problem sets are really, the reason I give you them is not really, I mean, it's a homework grade, so it is, obviously it'll help your grade if you do it. But it's really as a study mechanism for the test. That's why I give you problem sets. It's not going to affect your grade nearly as much as a test itself will. Isabella, Regina, Julie.
I just had trouble with
Okay, Joe, follow-up question on that or something totally different?
I have a question. I had trouble with one, and also Comset though is like a completion grade or.
No, correctness. Rom said is correctness. Homework is mainly completion unless I judge elsewise. Okay? If I feel like I want to grade them for some reason, I think people aren't doing it officially, then I'll start grading them. But problem sets are graded for correctness. Go ahead, Isabel.
So I just realized I did the whole wrong one. Like I did a different unit than I was supposed to. Like I still did the questions. So like what do I
You
do?
did a different unit?
Like I did the questions that were
In the oral exercises instead of written, or?
something like that. I just messed it up. Like I just did the wrong questions.
Well, it's up to you. I would probably resubmit it because if you're late, it's only 10% off your grade. Take a look at the numbers and see. If section 1.3 is 10% of the problems, right, or more, then it makes sense to redo it. If it's only worth like 5% of the actual total problem set, then it doesn't make sense to redo it all. See what I'm saying? Every day you lose 10%. So if you leave it the way it is and it's already submitted and all of 1.3 isn't right, but it's only worth like 6 points in the whole problem set, then you're better off just leaving it. But if it's worth more than 10 points, you might as well redo it and lose the 10% because it's late versus that. Does that make sense what I'm saying?
Yeah.
I'll be nice and I'll be a little bit more lenient because I know at least you did it.
I'm still gonna redo
Okay?
them anyway.
So then resubmit it and just write me a note at least at the top, okay? That says, I did this on time and I'm resubmitting 1.3. You could even resubmit just that section if you want, But as a whole document, maybe actually, it'd be easier.
I was having trouble with like the problem set, and also there was one other question, so I didn't do it at the question mark. Got your points taken off.
Yeah, it is for correctness. So when you guys have trouble on the problem set, that's why I encourage you to start ahead of time. So although, this is your first week, so this is like new to you guys, you can start the problem set for like 1.7 tomorrow if you want. Because the problem set for the whole year is up. So when you're doing this stuff, try to get most of it done maybe before yesterday so you could ask me questions instead of just today beforehand. Again, it's meant to be a challenge, okay? And I would not focus too much, guys. Homework is like 10% of your grade, and this is 1 point out of 75 out of 10%. So you're looking at like 0.3 on your quarter average maybe, not even that. You know what I'm saying? It's like a fraction of a small point on your quarter average. So don't worry about that as much. The tests are way more important as far as affecting your grade than problem sets are. But the problem sets themselves are there to help you study for the test. So still do them, obviously. But try to get them maybe a little bit earlier so you can ask those questions. Julia and then Valentina. That was the correctness one? Okay.
For some problems, I think I forgot to put like feet in the measurement. Like I put feet for number 2 in terms of jumps.
We'll see. It depends on the problem. I'm not going to go into how I'm going to grade everything right now, okay? But yeah, in the future, you should put units when units are given in a problem.
So I had trouble with
Yeah.
number 24 and 1-7.
1-7, number 24. Okay. Let's take a look. 3y minus 2y minus 1 equals -1 all over 6. So Isabella, I would start by multiplying by 6 to start. Distribute the 2 to both of these terms. That's a 3.
Yeah, I got that, then I got y plus 2 over 6 equals -1. But then I didn't know how to put that into my answer.
Well, be careful. Look, this is what I got. See, because I multiplied by 6. You had y plus 2 over 6 equals -1. Multiply both sides by 6 first and move the 6 up here. And now get rid of that. You subtract the 2, make it -8, y equals -8. Okay, so whenever you have a denominator, you get rid of multiply by. You guys can go. Go ahead. Tomorrow again, not tomorrow, your test on Friday. Oh, tomorrow after school I'll be here for a while. Today after school I will not. I have to go to the doctor right after school. Okay, so I had office hours this morning. I didn't see anybody, so I'm assuming you all feel pretty confident and stuff. But tomorrow after school we have open house for your parents tomorrow night. Please tell your parents to come tomorrow night so I can meet them. Okay, please encourage them to do so. Tomorrow after school they'll come by and want help with this test.
Are you
Okay?
Grade 6?
Grade 6.
There's a free today.
Activities on the
Yeah.
science club. Yeah, that's third period. I run science club. The second half of the period, you might be able to find me. So the first 20 minutes of third period, I'll definitely be in science club.
Like, I would come tomorrow, but I have practice.
We'll practice. I'm sure it'll be fine. I'll talk to your coach. Who's your coach? Who's your coach? Ms. Morano? Tell her you're seeing me for help after school, but I'll send her an email. It's not a problem. As long as it's not a game, right? Okay.
I did all the work and I did like everything that was there. I didn't realize it was all format until after I finished the work. Yeah.
Okay.
I didn't realize it was from after that.
I saw it, yeah. It's all right for this one, but for the future, try to use the format. Yep. Thanks, Christian.
So for tomorrow, I did it like and then I think I realized that I had this
For the one. You haven't done it. Did you drive?
everything's submitted, but I think I might have submitted it a little bit late because I didn't know it happened.
Okay. Good to know. Thank you. Thanks, Laura.